Okay, so starting out with, now we are going to be working on finding the domain of these composition functions. So same functions that we had on the last one. Um, we've got f open circle g of x, where f of x is 1 over x plus 3, and g of x is 1 over x minus 4. Now, just like when we were doing the domain of the operation of functions, there are two things that we have to pay attention to. Now, to think about what we need to have paying attention to, let's go back to what we did on the first slide here. Okay, so remember we had our picture here, and you are going to have your x value, and that is in the highlighter. I always do that. Now, what is the first thing? Because remember, we're always thinking about our input goes into our function. We got to know what inputs can go in. So the first thing that the input does when it goes into the function is it goes into this g function here. So that is why when we solve these here, f open circle g of x, that g, whatever that letter is there, is the first thing the x will go into. So the first thing that we have to do is we have to know just strictly what is the domain of g. And again, just to reiterate, f open circle g of x is f of g of x. Okay, so the first thing that we have to pay attention to is your g function. So our g of x is 1 over x minus 4. We need to know what is the domain of that g because that's the first thing that x goes into. Okay, so what would our concern be for this function here? Well, we should be worried about dividing by 0. So we need to make sure that what's on the bottom, that x minus 4, cannot equal 0. I'm going to add my 4 over, and I find that x cannot equal 4. Okay, so that would be negative infinity to 4 in union with 4 to infinity. Okay, now hypothetically, let's say that we were doing g open circle f of x and finding the domain of that. Well, this would be g of f of x. So the first thing I would want to do with this one here, since the f is in that spot, I would need to find the domain. Oh my goodness, why do I always do that? I would need to find the domain of f first. So it's always whatever the second letter is. That's the domain that you have to worry about. And that is because that function is the first function that your x goes into. Okay? Now, second one here, because there's a second part of it. We need to find the domain of f open circle g immediately after I plug in my g of x to my f of x. So, why is that? Well, if we think back to our last video there, what happens here? Well, after my x enters my g, the output comes out, which is g of x. And then that g of x output is going to get plugged into your f output. So we're not, on this one here, I was concerned about what is my x value going into my g. Now I'm concerned about what g of x value is going to go into my f. So I need to look at this immediately after I plug it in. Okay, so down below here, you guys can see I've got f parentheses g of x close parentheses. So when I've immediately plugged it in, that would be this section right here where I've immediately plugged that in. What would my domain concern be for this one? Okay, so that's what we're going to ask ourselves here. So again, just to reiterate, oh my gosh, we've got f of g of x, and that is 1 over x minus 4 plus 3. Okay, so what would our domain concern be for this one here? Now, a lot of people will look at this and they will say, oh, your domain concern is going to be that x minus 4. We already checked that out on that first one there. We already checked it out with our g. So now our only concern is going to be when this whole bottom here, we are concerned about division by 0. You are correct on that. But we're concerned about when the whole bottom of that equals 0. Okay, so 1 over x minus 4 plus 3, that whole thing cannot equal 0. Okay? And the reason, again, we don't have to worry about that x minus 4 is because we already checked that x minus 4 with our top one there. Okay, so to solve this, I'm going to subtract 1 over x minus 4 cannot equal negative 3. I like to set these up here and then just cross multiply. So negative 3 times x minus 4 cannot equal 1 times 1 is just 1. So that's 1 cannot equal negative 3x plus 12. So 1 cannot equal negative 3x plus 12. Go ahead and keep solving. Subtract my 12. I get negative 11. Cannot equal negative 3x. Divide by negative 3. And I find that x cannot equal positive 11 thirds, which would be your negative infinity to 11 thirds in union with 11 thirds to infinity. Okay, so we have our two cases. And if we go back up to our picture, we're worried about x getting plugged into g. So we checked our domain of g. Then we're worried about g of x getting plugged into f. So we looked at that example where g of x was plugged into f. Okay. Now, the last thing you have to do is just like on our operations, we're going to try and find the overlap between these two. So we're just going to need to graph these. And I've got my first one that says x cannot equal 4. So x is going to equal everything else. My second part, I found that x cannot equal 11 thirds. Okay, and 11 thirds is really 3 3/4. That's how I knew it was below. But it can equal everything else. And just like before, our solution to this is going to be the overlap of all of these values. So what does red and blue make? Well, it makes purple. So here I see red and blue. In between them, I see red and blue. On this edge, I see red and blue. Now at 4, I only see blue at 4 because the red is an open circle. And then at 11 thirds, I only see red because the blue is an open circle. So our answer is the overlap everywhere that we made purple. So I would say from negative infinity to 11 thirds in union with 11 thirds to 4 in union with 4 to infinity. And that is the domain for our composite function that we have there.